Hey class, I'm back. I apologize that I have to remake this video. When I did it with no sound. And that is another thing. I always try to check it after I create a video. And I didn't check it right after I did it because I was trying to upload it, but I realized there was no sound on it. So this video, you all are able to hear me, and I apologize for the delay. But I'm going to finish up right now exponential functions. We're going to go over about the graph of an exponential function so you all know that real quick. Now, here's exponential function. Remember, A is your base, X is your exponent, and that base has to be positive. It has to be either greater than 1 or between 0 and 1, okay? Right now, we're talking about if A is greater than 1, what it looks like. So let's add this to it real quick. A greater than 1. Also, right here, you can see this is the graph of it, and also when A is greater than 1, right? Domain for this is, your domain can be anything. We can put anything in for X, all real numbers. But you all, no matter what we put in, when you raise a base to an exponent, whether it's negative or positive, it stay positive. So your range come back positive. So 0 to infinity. Can't be 0, but it get close to 0. It won't touch 0. It won't be 0, but from 0 to infinity. Look at the table right here. Now, this table is in particular for this right here. It's for this 2 raised to the x. That's what it is. So that's the table for. But what I want you to see that is when you complete the table, these are the numbers that I want you to use for your table. I want you to use -2 to 2, right? That's what I want you to use, from -2 to 2. And then you plug it in for whatever your exponential expression is, okay? So we're going from -2 to 2, right? On the graph, when you're doing this, these 3 points will be on your graph every single time. These 3 points right here will be on your graph every single time when you're talking about an exponential function, right there, okay? Every single time. Now, you see it has A in there because it determined what your base is. So here, your base is 2. So you're going to see -1, 1/2, and you're also going to see 1, 2. But if your base was 5, then it would be -1, 1/5. Just give you an example. So those 3 points every single time you can plot, okay, for sure, and they should be on the graph. Now, look at this function. Let's look at it. Well, how does it look? From left to right, doesn't it go upwards? So it's increasing, okay? So it's an increasing function, and it's continuous on the domain. And the domain is all real numbers, and negative infinity to positive infinity, okay? So it's an increasing function. This is when your A is greater than 1. It is when your A is greater than 1. It's an increasing function over the entire domain. Next, what we have is the x-axis. X-axis work as the horizontal asymptote. You all see it gets close to x right here, right? X-axis, y'all see? They get close. Even if you look at this one, isn't it get approaching the x-axis? Now, look at the 3 points that it'll always pass through. It'll pass through -1, 1/a, 0, 1, and then it'll be 1a. So these are the 3 points that it will always pass through. Now, this is the graph when A is greater than 1. Let's talk about when A is between 0 and 1, right? So once again, we got a function equals A raised to the x, and you have 0 is in between, A is in between 0 and 1. That's what we're talking about. This is what we're referring to now. Still an exponential function, but we have a small number for our base. It's positive, but it's small, okay? And look what we have. Our domain is still the same, -infinity to positive infinity. Our range is still going to be the same thing, 0 to infinity. Now look at this graph now, you all. Look at this graph now. This is the graph of it now. Right, look. From left to right, y'all see what it's doing? It's decreasing. Decreasing. Even here, this is it on a calculator if you put it in a calculator, right? And look at this example. They graph in 1/2, you all. They're graphing 1/2. They're graphing 1/2 as the base, okay? Like I said, I want you to use -2 through 2. So -2, -1, 0, 1, 2. That's what we use, and I don't use -3. But really, you can do these three. These are the three that you can really plot, and you can see that it'll give it to you, okay? Now, just by me showing you this, let's fill this in. What is this? Decreasing and continuous on our interval, on our interval, entire domain of -infinity to infinity. Once again, x-axis is the horizontal asymptote. And once again, no matter whether it's a small a or a big A, it's going to hit these 3 points. -1, 1 over A, 0, 1, and it's going to hit 1A. Every single time, those 3 points will be on the graph, no matter if your A is small or if your A is big. Those are 3 points it will hit. Okay? Now, let's graph some of these. I don't spend a lot on just graphing all day long. We're going to do a couple of them, okay? I want to see. Now, let's talk about the characteristic of this particular function, any exponential function. The points, -1, 1 over A going to be on there. The point 0, 1 going to be on there. And the point 1A will always be on the graph. Once again, A is the base. If A is greater than 1, that means it's a large number. It will be an increasing function. If A is a small number, that means a decimal or fraction. That's between 0 and 1. It will be a decreasing function. Remember, the x-axis is the horizontal asymptote. And the domain is always all real numbers, which is -infinity to +infinity. And our range is going to be always 0 to infinity. Okay, and we're just talking about the original. Nothing's been added to it or subtracted from or multiplied to it. Now, let's graph this, right? We got the domain. We're graphing this real quick. I say graph f of x equals 1 over x. 1/5 over x. You all, we got to give domain and range. So let's create our table. Remember, I said, you all, for me, just do -2, -1, 0, 1, 2. That's all I want you to do, okay? Now, look at where you're putting this, because I want you to be, look, this is your x. Your x is your exponent. So as you're trying to calculate this, you're saying, sorry, let me get back in the right mode. You're saying 1/5 raised to the -2. That's what you're saying. And 1/5 raised to the -2. Remember I talked about negative exponent. You flip it to make it positive. You do. I've said that, flip it, make it positive. So when I flip it, I make it a positive, it becomes 5. And then my exponent becomes positive, which gives me 25. Okay? The next one is -1. Look, 1/5, -1. Remember I said flip it to make it a positive exponent. So when I flip this number, that becomes 5 and it becomes positive. So that's just 5, right? The next thing, 0, anything raised to 0 power is 1. Always 1. The next one, when we raise that to the 1/5 raised to the first, isn't that just 1/5? Okay. And if we say 1/5 raised to the second power, that's just saying 1/5 times 1/5, which gives us 1 over 25. Okay. So let's graph these real quick. Now, you all see that we can't get as high as 25, but we should be able to graph the rest of these. Okay. So -1, 5 is here. 0, 1 is here. 1 and 1/5 would be so close to 0, but not quite. And then 2 and 1/25 would be so close to 0, but not on 0. Okay. Now let's connect these. And that's how we graph that one. It'll get close because 1 over 25, if you put that in the calculator, is 0.04. That's very close to 0. But we can't let it get close to it. Won't touch it. It won't cross over it. Just get close to it. Okay. The next one, real quick. And I'm just going to graph this one real quick for you all. Okay. Oh, what we forgot to do here is say domain and range. Sorry, because it says give domain and range. Apologize. Domain. We're looking at left, right. You see left got an arrow, right side got an arrow, negative infinity, positive infinity. Range. We're talking about the bottom of this to the top. The bottom starts what? Close to 0, all the way to infinity. Okay. Now, last one we're going to do with the graphing, you all. Last one we do with the graphing. Okay. First thing we need to do is come up with the table for just this function right here. That's what we need to do. Let's do that real quick. All right. -2, -1, 0, 1, 2. That's what we have. Now, if we're doing this function right here, remember, this x that we're plugging in is your exponent. So you're saying 2 raised to the -2. Flip it, right? So you get 1 over 2 squared. That's how you, because that changes the exponent. And that gives you what? 1/4, okay? Then this one would be 1/2. 0 raised to anything is 1. 2 to the first is just 2. 2 to the second is 4. We have that right there. But you all, look at this. Look at what this has. This says +3. And that's added to x. Think about when we did it prior. Anything added to x said it was going to move left or right. That's what it said, right? So think about it. If it's added to x, and if you take this statement and solve it, if you take x plus 3 and solve it, we get x equals a -3. That tells us the direction. So it should be moving, this graph should be moving to the left, 3. Is everybody with me? This is the number you have to add to your x values. That's all you're doing. You're doing what we've done in chapter 2, okay? Except we're dealing with exponential. So let's add 2 here. Sorry, not 2, we add -3. We add -3 to each one of our x values. Look what we get. -5 here. -5 there. We get what? -4. This becomes -3. And this becomes -2. And this becomes -1. So you see how our values change. But it's a horizontal shift. This is something horizontal because it's attached to x. Okay, so let's do it. -5, -1, and +1/4. So that'll be about, let's say about right there. Then we have -4, 1/2. That'll be about right there. And we have -3, 1, which is here. Right? And then what's the next thing? -2, 2. And -1, 4. Yeah. Looks like it's forming that curve, right? Okay. Now, y'all see, it shifted over 3 units to the left. We see that, right? It shifted to the left. Okay. So look what we say here when we talk about domain and range. Let's look at left to right, left, right, left, right. Both sides got an arrow. Left, right. Okay. Negative infinity. Sorry, excuse me. Negative infinity to positive infinity. Let's talk about range. Bottom, top, bottom, top, bottom. Right here. What is it close to? Gets close to 0 still. Okay. And then goes to infinity. Okay. I'm only doing these 2 graphings, so this should help you out with the graphing. I'll be back to do the rest.